Today we're going to be talking about HHVM and how HHVM came to be at Facebook. So HHVM is a JIT compiler developed by Keith Adams, right here, Jason Evans, and Drew Porosky. And this is the HHVM story. I'm Julian. I'm the CEO of Skip Labs.
So I'm Keith Adams, sometimes known as KMA for my login at various companies. These days, I'm founder and managing partner at Pebblebed, an early stage VC firm that works with technically ambitious founders.
You managed to do pre-IPO and pretty cool companies like 3 times, right? Among engineers, you're like that guy, wherever Keith is going next, that's where we need to go, because VMware, you were employee number what, 80, something like that?
Yeah, like just under 100, I think, about 20 engineers. So, this wasn't like 2 guys and their dog dreaming about virtual machines or something, right? There was like a real direction set and a product and customers and things. But honestly, like VMware was just kind of a lucky hit, right? Like I was graduating from college in 2000. I went to Brown University. A lot of really bright people from the computer science class as at Brown ended up at Sun Microsystems, especially people who were excited about OSs and CPUs and the things that I was excited about. I had an offer from Sun Microsystems, actually, which I was incredibly excited about. But there was also this crazy VMware place. And when I went to see a talk by a guy named Ole Augustin, who I had the privilege of working with for 9 years at VMware, he came to Brown University and gave like a pizza talk about how this thing worked. I thought it was amazing. I thought he was amazing. I thought, wow, I've got to expose myself to this person any way I can while it's still an easy decision to make. And if this VMware thing blows up, hey, at least Sun Microsystems will always be there. Which of course, ended up being the opposite of how this all worked out. Pache, my friends at Sun, who went on to do amazing work in the 2000s. It feels like a ton of luck. It was an incredible place, really brilliant people, really, in hindsight, like really high standards of sort of technical excellence, really high standards of just like what it meant to do a good job and what it meant to ship something quality to customers and how good things really needed to be before they were sort of ready for other people to consume, which I'm glad I've had those standards kind of imbued in me relatively early. After the 2008 financial crisis, VMware had already been acquired by EMC at this point. EMC had just like decapitated VMware. Had just gotten rid of Diane Green, who was the founding CEO of VMware, and had sort of started absorbing VMware more into EMC proper. There was a lot of kind of general bad vibes, I'd say, among the rank and file at VMware. Certainly for the first time, I'd always assumed VMware was going to be my entire professional identity, right? I was 30 years old at this point and had been there since I left college. And for the first time, I thought like, well, if Diane's disposable, I guess I'm disposable too. And what does that mean? And there was a recruiter at Facebook named Sarah Kurian who got the VMware, got the phone book, basically. But this is back when people had landlines on their desks at work, right? So this is the little Cisco phone that you pick up. And she war dialed the VMware directory for engineers. And like anybody who picked up, she was like, hey, my name's Sarah. I'm a recruiter from Facebook. Like, can I get coffee with you? And 99 times out of 100, I'd have probably said no. But of course, this was the week to do it. And that was why she was doing it. And kind of one thing led to another.
So that's actually funny because the way I was recruited at Facebook, originally I didn't want to join Facebook at all. I wanted to join Google. And for me, Facebook was not serious people. So, for me, Facebook was just a bunch of clown pushing PHP, don't know what they're doing whatsoever. And I was working in a startup back then in Mountain View, and a recruiter from Google contacted me. And my roommate was working at Facebook back then. I don't know if you remember Pad.
Yeah.
And Pad was like, well, you should definitely try Facebook. I'll refer you and whatnot. So I tried a loop at Facebook, but really my mind was set on Google. And it was the interview process, and you were actually part of it. Like the crowd that interviewed me, my screen interview was with Jason Evans. Let's start with that.
Awesome.
The screen, right? And so
chef's kiss,
I have him on the phone. I mean, he's great. I love him. I have him on the phone, and he says his name, but I don't recall. I'm like, I don't pay attention. I'm like, okay, well, let's do the interview.
By the way, Jason Evans still of J.E. Malik fame, I would say, right?
Exactly.
He probably wrote the memory allocator you're using to listen to this, for instance. Sorry, Julian, go ahead.
And So that's actually what I said. I was like, well, wait a minute. You're Jason Evans from J.E. Malloch? And he's like, yeah. I'm like, I know your stuff. And I started talking about his code. I mean, it's pretty cool. You have cool data structures in there. And that was amazing. So then I wrote some code, which I'm sure was wrong. And I think at the end he said that I'm pretty sure that's wrong, but I wouldn't be able to tell you why. and so and so that's how I passed that interview. And then the crowd was great. I had Ben Matthews who interviewed me.
Yeah.
I had you. You was a pretty good one. It was like, well, how do you write a garbage collector? What's a garbage collector? What are the trade-offs of a garbage collector? And we started, ranting about garbage collectors. And yeah,
I
I
remember,
walked
I
out.
remember there was something loopy in it because you were writing OCaml and you sort of like wrote it a little bit like it was C++, like you wrote it with like a bunch of loops constructs in it. And I was like, let's be OCaml programmers. Like go ahead. Like, I get it. Like, I'm a C++ programmer, but do this idiomatically for my benefit, please.
So actually, I was dumbing it down for you, Keith. I was
no.
hoping that,
Yeah,
the C++
exactly.
programmer you are would not understand the OCaml beauty. So no, but in all seriousness, it was a really cool interview. And I walked out of it thinking, wow, I really want to work for Facebook. They have really cool people there. I think
And in
that's,
hindsight, by the way, Julian, I probably had a similar set of preconceptions, right? So,
yeah.
I guess a little bit of backstory here too, by the way. Like when I was interviewing in 2008, they actually hadn't been in Silicon Valley for very long. They're a recent transplant from Boston, right? When it was a Harvard startup, and the kind of perception of them among locals, which like mostly didn't know a lot of people who worked there, was like, okay, there's this weird thing. It's a big hit on college campuses or something. And the assumption was that these are people that like maybe had some product sense, but that there was no sort of serious technology going on. And so I wasn't really sure what I was getting myself into when I showed up for an interview. Jeff Rothschild was the first person that gave me the interview there. And I'd like had some contact with people from Veritas, in the process of working at VMware, because Veritas kind of was deep in the DNA of System Z Silicon Valley at the time. And he actually kind of negged me a little bit about VMware in the interview. He's kind of like, yeah, this stuff's kind of good for test and dev, I guess, but like nobody's ever going to run that garbage in production. And I was like, well, actually, sir, I mean, they kind of do use it. So, kind of put me on my back foot a little bit. I wasn't expecting to have to defend the validity of what I'd been doing for the last 9 years. Like I thought I'd be teaching these PHP bozos a thing or two about how computers worked. And it was a little bit the other way around. And Bobby Johnson also,
Bobby
just a bunch of
Johnson
other
is
really bright
great. Yeah.
people.
Yeah.
Facebook at some level was like, in terms of its impact on the economy, it was a pump that turned venture capital dollars into top line for network appliance for NetApp, right? It was storing photos in these big NetApp filers, many, uncountably many petabytes of this stuff, because it had a huge hit on its hands for photos. It was like the first time people in a mass consumer way were really sharing photographs with each other online. There were things like Flickr, but they were kind of for prosumers who were hobbyist photographers. It wasn't like normal people snapping photos with their cell phones and things until right then. And so those were extremely expensive ways to store those photos on the one hand, but they needed kind of fast, reliable storage of all these things.
When I joined, one of my goals, and in fact, it was, during the onboarding, there was one day where they asked you, where do you think you could have impact for Facebook, da, da, da. And there's a piece of paper where you wrote it down. And I wrote down that I was going to make PHP better. That this was shit. This is not, this is not going to, I wasn't going to leave it at that. I mean, I spent a bunch of years working on, critical embedded software. So, compilers for things that end up in Airbus, in trains, in planes, in nuclear plants. And I mean, kind of things where if the software fails, people are going to die, kind of thing, right? Hence the name safety critical software. And when we were writing code at this first company, the goal was zero bug, right? If you had a bug, you had to email all your customers. It was very long and complicated process. So the goal was really to get it down to zero bug, no matter how long it takes. And from that to dub, like the PHP code base at Facebook, was like, whoa, this is so. And in all fairness, it was actually a pretty good code base. Like if I compare to other companies that I worked for afterwards,
especially for being like a paleo PHP code base, right? Especially for being a code base that never got rototilled from Zuck hacking away in his dorm room in 2004 or whatever.
Yeah. I mean, the
yeah, I
one
agree.
thing that I would say was detrimental to the quality of the code was that they would never finish transitions, so migrations. So they would start migrations to new things, and then somebody would come along with a new idea, and they hadn't finished off the migration before. And so what ended up
one of my sort of party tricks I would do in boot camp as late as 2015, right when new people would join the company, was actually doing a little tour of places in the code where things still get blamed to Zuck, and you could still find like SQL string constants that are like select star from users where ID equals blah. That's like get blame Zuck or whatever. And is that code even live? Probably not. Actually, there's probably like no way to actually get to that code in the code base anymore, at least not with any URLs that are live. Sorry, I didn't mean to interrupt your story there.
no,
But
no,
again,
but
the transitions went all the way down to the unfinished transitions go all the way down to select star from
Zuck.
users where ID equals.
Yeah, exactly. I mean, that was also the first stuff I was working on, right? The first stuff I was working on at Facebook was static analysis to find security holes. And in fact, I was very surprised how well the technique was working, because normally, in a dynamic language, you really don't get very far. And the reason is relatively simple, which is that if you don't have the types, you lose the control very quickly, right? The moment you call a method, if the method has a somewhat generic name, like render, if you're rendering HTML, you really don't know what you're calling, and therefore you really don't know what to analyze, and basically your analysis is not going very far. But I was still able to build an analysis that found a lot of security holes, because there was a lot of old style PHP, where everything is a top level, the kind of stuff that you're describing, like SQL queries, where clearly it wasn't escaped the way it was supposed to be escaped at all. And so we were able to found a lot of interesting bugs this way back in the code base. I think it's cool for us to say that now. It has been, 15 years? Because,
the statute of limitations on all this is expired, right? I assume it's all like outer space, laser beam, sci-fi now. And if it isn't, some reachability analysis has been performed or whatever.
Because 15 years ago, I would have been wary, saying that there was security holes within Facebook. Because, that was my job, and I didn't want too many people to know outside of Facebook that this was the case. But there was this funny story of a guy who built an endpoint. So I was in the security team. That was my first team before joining HHVM Hack. And there was a guy who built an endpoint, and the endpoint was literally take the parameter and run it in hypershell. So hypershell being the shell that runs this command as root on all machines in production.
Oh yeah, the root production command. Yeah, the destroy all of production.
So he had a little web page, a little internal web page where you typed any text you liked, then you press run, and the thing runs roots in production everywhere. So then I have this static analysis that immediately goes like alert, alert, what is this? I can see the veins of Erling, who was working on the team, like his veins were pumping, like what the fuck is this? And he went to see this guy, and the guy was like, yeah, but it's really useful when I'm on holiday, I can push stuff in production. And I saw the moment where Erling was going to strangle him. It's like, shut up. And I mean, it's just to give you an idea of how far things were back then. We went from, cowboy land to something actually pretty serious. Like if you wanna hack into Facebook these days, you better.
Yeah, it's a pretty major project, I think. Right? That's there's some pretty serious professionals who've hired it. We're talking about like the mid 2000, the early 2010s, roughly, right? Like late aughts to early 2010s. Like the people that started to sort of come into Facebook at that time might have had backgrounds that were more like yours and mine, where lives are on the line or billions of dollars were on the line, or, there's an expectation of fitness to purpose of any of the software you're making that wasn't necessarily there for internet products, that were just sort of consumery before. I think like, there was a time with Facebook where you could kind of be like, well, we're not negotiating with aliens for the future of Earth, right? These are just people posting pictures of their cats. Like, it's more important that this be
Yeah, it's
fun
true.
and easy to
It's true.
iterate on than it is that, like, we're not, lives aren't on the line broadly. But past a certain point, like, there's sort of so much value and sensitivity and private data and everything else involved that, like, lives essentially are on the line. I was always pretty impressed how seriously people took that responsibility. It's impossible to do it perfectly, if that makes any sense, right? So, for example, like, there was a conflict happening in a region, right? And like a civil war, basically. And it's a civil war where, like, nobody in the Menlo Park office speaks the local languages. Okay, this is before AI, right? We can't just translate it. We can't just read the messages. And it comes to our attention that people are using Facebook Messenger basically to organize roving gangs, right? To organize, like, groups of people that are going out and killing other people. Now, we have no context about this civil war. Are these the good guys? Are these the bad guys? Does the concept of good guys and bad guys have any relevance? We have no bloody idea, right? Do you want to turn Messenger off in that region? Is that the right thing to do? Again, AI doesn't work. There's not like some neural net you can snap on the front of it to try to classify messages as being, like, potentially about violence or something like that. And I mean, this was a pretty big emergency that ran for a while, and there was no kind of obvious commercial impact. It just was literally lives on the line. People were using our communication product to do stuff of extreme consequence. And it reminded me, like, it was a strange problem. It sort of reminded me a little bit of a capitalist version of the socialist calculation problem. One of the reasons communism ends up being really hard to do in practice is that economies are chaotic, right? If I'm trying to make a plan for the economy of the Soviet Union, and I'm trying to figure out in 3 years or 5 years, one of the things I need to figure out is, like, how much yellow paint are we going to need in the city of Kiev 3 years from now? And that's, like, almost impossible. The information doesn't really exist. Like, you need things like price signals and, companies getting created and destroyed to kind of actually meet that demand. And this was like a weird consumer internet version of that, if that makes any sense. It was like there's sort of so much power concentrated in this one platform that there was almost no way to wisely wield that power. And I don't know what to do about this observation, by the way. I don't think there's any sort of super clear, it's sort of a civilization-wide question, like, what you should do about this.
I remember some of those problems too, and there was no clear solution, and also there was a lot of suspicion um, in the towards the company back then. I remember especially when there was the bug where apparently Facebook was publishing all your private messages on your
Oh, yeah, this is really
timeline.
interesting.
You remember
Yeah,
that?
yeah.
Back then I was working at Facebook, you were too. And I had a bunch of friends who just wouldn't believe me. They thought it was a cover up, because the real story was before, at the beginning of Facebook, there was no Messenger and there was barely anyone on Facebook. It was your wall was you and your 5 friends. And so people were
And there wasn't
talking
a
to
news
each
feed
other.
either, by the way, right?
There was no news feed either. Yeah. So
ersatz distribution of content, right? It was like you'd go to from profile to profile. I'd go to Facebook to, like, look at your profile.
exactly. And so what people were doing is they were messaging each other on their wall directly. And so the once timeline was launched, basically you would take all these old messages that were on the wall that have always been public, right? But now they're in a form that looks like private messages are actually on your wall, or were brought into your wall, except that they've always been there, right? So
Yeah,
all the media in France went nuts,
right.
including medias that I really trusted, like newspapers I had been reading forever, and they published this thing that there was this bug at Facebook, da da da, and
Same thing happened in
so
the States, by the way. The New York Times is all over
yeah,
this. Like,
yeah.
name your favorite. I assume Le Monde is one of the ones you're thinking
Le
of. I
Monde
remember Le
is
Monde
the one
being
I
on
was
it.
thinking about,
Yeah, yeah.
and what really surprised me is that no journalists, no team, no newspaper, nothing actually corrected themselves. Because the fact that they made a mistake, that was one thing,
Right,
that
right.
happens. But there was, in Le Monde, which was a newspaper I read for many, many, many years, all we had in there was page 34. There was a little article that said, oh yeah, Facebook maybe didn't really have a bug, but that doesn't mean anything because there was all these other bugs that were there before, and those
but
were
it's still
real.
bad, actually.
Exactly,
You should still
bad,
hate them. Don't worry. You should still think they suck. And it's like, okay, cool,
you're like, okay, so truth doesn't really matter, right? Like, it doesn't matter that there was no bug, that this is all blown out of proportion for nothing at all. But I mean, it changed my perspective on many things because, I mean, if, today I was asked to actually run a social media platform, I think I would struggle, like how getting
because you
that
know too much
stuff.
about what can go wrong, basically. Because you know too much about,
Exactly.
You'd be sort of hemmed in. Yeah, I know what you mean.
You're like, either you make it too restrictive and then your network is never going to grow. Nobody is going to, because they're going to feel like imprisoned, like they cannot say the stuff that they care about.
Mm-hmm.
Or you open the gates, but then, you end up in this cesspool of hate. I mean,
Right.
not to point at some specific, social network that has done that recently, like open the floodgates and see what happens. But it's, I mean, don't get me wrong. I'm in favor of freedom of speech, and I really believe in freedom of speech. But yeah, running a social media platform is rough. But tell me more about. I want to hear the story about HHVM and
okay, yeah. So
how how
we're
we
saying
got
this
to
back
that.
and forth to each other, and like normal people don't know or care what the hell this thing is. By the way, so we
Of
should.
course, everybody knows what HHVM is. There's Taylor Swift,
the kids today,
Michael Jordan.
Yeah.
HHVM, of course.
Yeah. So HHVM, which stood for the Hip Hop Virtual Machine, a little bit of a long story on the name, was basically a JIT compiler, a just-in-time compiler for PHP that me, Jason Evans, who we talked about a second ago, and Drew Porosky started working on in 2010, and eventually delivered to production in early 2013, late 2012, and it was a reaction to kind of economic pressures actually that Facebook faced in certain ways. So, you hear a lot about compute costs in the context of AI right now. In the microcosm of Facebook, we were spending a lot of money on compute per user at the time as well. It was one of the things that actually kind of threatened the economic model of Facebook, in part because the ads model hadn't really taken off yet at the time we started this. And the amount of CPU we actually had to spend per user to run the site was really, really enormous. And a big chunk of that we felt, and we had some reason to believe, was because of the PHP language, which is it's a developer productivity language, right? It's interpreted language. It's, really easy to change. It's really easy to get started with, but it's really, really, really free with its use of CPU resources and memory resources. And so you have to buy a lot of computer if you're going to try to run a mass market site with it. And we were trying to do something to tamp those resources down. This is the second major effort that Facebook undertook to get this problem under control. And the first one was called Hip Hop, or originally was called HPHP, because Haiping Zhao, an engineer at Facebook before I started there, got it started. And then it turns out that PHP is a trademark that's owned by like a company in Israel, and they're a little bit litigious, and some words were exchanged. And so if you sort of grep for HP in user dict words, you'll find like hip hop and not that many other words. So hip hop was the name of that thing. And it was an ahead of time compiler. So it worked, the way your C++ compiler works, or your Go compiler works, or your Rust compiler works these days, where it like takes this gigantic code base that was, dub, which we've referred to before. And it spits out an ELF binary. It spits out a thing that listens on port 80, the same way that a static language compiler would. We should also mention, not only is Facebook kind of a PHP application at this time, it's a PHP monolith. It's one big PHP application. So that
back
blue
then
site,
it's like 80% of the Facebook code is PHP, right? Something like that.
Exactly, something like that. At the time, a gigantic amount of the intellectual property and the thing that makes Facebook go is this one repo in PHP. And it was a sort of understanding across the engineering organization that there was a, big, hairy, audacious goal would be make dub run fast. And one approach to do that is like take it all, turn it into C++, run it all through GCC. And that was what hip hop did, what HPHP did. And do you want to?
The original goal was not that, right? The original goal was actually to transpile it to C++. and then get all the PHP developers to switch to C++ to develop the web backend, right?
I
That
mean,
was
this is a slightly, you're right. This is a little bit of a side quest here, but Hyping, was a C++ programmer, like a lot of people who were coming into Facebook at the time, and kind of squinted at PHP from across the room, said, "Hey, there's curly braces, there's semicolons. Like, what's the problem here? This is basically C++ anyway. If we just kind of turn this lame, slow PHP code base into a beautiful, fast C++ code base, then we can really start cooking here." And so the idea was really initially that like you'd run it one day, check in all the crazy C++ that you generated, and then move forward into a glorious C++ based future. Um, this proved to not be the way that things could work. It turned out there were reasons people liked PHP. Some of those reasons included the kind of interpreted workflow, right? That I like save one file and can, see what happened.
Yeah.
Whereas if, you've got, at this time, it's already like tens of millions of lines of code. It's already a huge application where if you've got some huge compile cycle in the middle of that really kind of messes that flow up. So that would have faced enormous, like people would have just quit their jobs who worked on the product side of things.
I mean, imagine the compilation time, right? Imagine you're working on www in C++.
Yeah.
And in a code base that hasn't been thought out for it. Imagine the compilation time of, getting anything done in www, right? You would wait hours to compile anything.
PHP has no concept of a header file, right? So there's no, there would be a lot of work getting it into the shape where it's sort of a project that you can actually work on in an incremental way. In a way
I don't think it was possible. So I looked into
Yeah.
that back in the days because I wanted to, in fact, Pad was the first. So Johan Padiolo was the first to go on this crusade to try to split up the code base into, clean submodules and get the dependency layout figured out properly. And he went into this whole visualization tool that was called Overlay, something like that, that would show you the code base and the different regions of the code base and what depends on what. The problem is that there was no incentive to go after that. But to give you an idea, there was chunks of code with cyclic dependencies that would pull in more than 8 million lines of code.
Yep, exactly. Right. This is the problem. Is you end up with like some big cycle somewhere that like where the bottom calls the top and now you're done.
Because of autoload. So the fact that, whenever you use a class, it's just automatically loaded by the JIT, same with functions. There's no reason to pay attention to dependencies, right? If something works, you're just going to use it and it works, right? And if you don't pay at all attention to dependencies, you end up in really interesting situation where we had the logger that depended on end and stuff like that because, there was some useful method in there.
And if I could observe something too, by the way, this is like a, very broad, very abstract claim that like you should not, please don't bet your company on this advice, okay? But broadly, like there are clean engineers and dirty engineers. Like this is something I've observed, and has nothing to do with, that's not a quality judgment. I actually like dirty engineers. There are great dirty engineers. There are dirty engineers that like can do incredible stuff. Julian, I think of you as a very much a clean person. Like anybody that can do something new with a type system, you're probably a clean temperamentally. Clean people find me dirty. Clean people like find me hard to work with because I'm making these layering violations all over the place. On the other hand, really dirty engineers find me kind of persnickety and like I'm somewhere in the middle, basically, right?
I mean, it's funny because I see myself as in the middle too. Like what's interesting is, I mean, in my world, building a type system for PHP is the dirtiest thing you can do. Right? I mean, imagine you go to a type system conference and you're the PHP guy.
I'm sorry. That must have been hard. Yeah,
it was hard.
Yeah.
I mean,
do people speak really slowly to you? Do they like make? Were they like, so a type is a set of values. Some values are in the type, but other values aren't.
Are not.
Right.
Yeah. No. I mean, it was harder than you thought, and so what's interesting is I see myself in the middle too. So I agree that temperament has a lot to do with it. But it's not the only thing. The other thing that can matter is where are we at in the life of a project.
Right.
So if you're starting a project and you don't know if it has value yet, I think you should be as dirty as you can be to get to that information. While if you are, later down the lifetime of the project, then you should pay more attention. Another distinction too between clean and dirty engineers is another dimension, sorry, is people who like to start things from scratch
Yep.
and people who like to maintain or optimize what's there.
Yep. Yep.
And you need both. And what's interesting is that both classes of engineers tend to despise each other. So you've got,
Yeah.
the
They view the
people
other
who
side as like not solving any of the real hard problems or
exactly.
whatever.
So
Yeah.
you've got the people who are maintaining the existing system and optimizing for it. And like, oh yeah, all these clowns, building this pie in the sky project that's never going to go in production. Like this is all bullshit. What we're doing the real work. And
Yeah.
then the other people, who are building the new system, they're like, oh yeah, all these clowns maintaining this old ass code base going nowhere when the new shit's going to solve all of that. And so
Yeah.
what's
Yeah.
interesting is that you need both, and sometimes they are both right and sometimes they're both wrong. I've
Yep.
seen people cling on to old shit that was going to retire. Like I can remember some people still optimizing HPHP a couple of days before HHVM was entering production. And at some point you're like, dude, let it go.
Right. Right.
And at the same time, I've also seen the other way around, like people going off building new shit, like rewriting everything in Rust. That is, let's rewrite this in Rust. It's like, why? It will be faster. Do we have performance problems? No, but it will be faster and greater and better. But
and memory safe. Yeah.
and what problem are you solving?
And make massive mistakes you don't make.
And
Rust,
so,
by the way, is a fascinating talking about this like dirty clean thing. Like Rust is like the clean's attempt to remake the world, right? It's their attempt to sort of be like
remake the C++ world, not the entire
sure,
world.
sure. But like, what if we kind of wipe the earth of like these nasty things in C++? And I find it fascinating. This is not a novel observation, but I do find it fascinating that like we've got a whole bunch of Rust platforms at this point and not so many Rust products that anybody finds compelling, right? Like there are far more Rust game engines than there are Rust games you want to play.
Yeah.
And there's at least one person who's suggested that that might be because like layering violations are where fun and surprise kind of come from, right? That like that you need to be able to try weird shit in a game, like both as a player and as a developer. You need to be able to kind of be like, well, what if this happens or whatever.
I mean, I want to talk shit about Rust for a second. So first of all, before I talk shit about Rust, I was a huge believer in linear types, unique types, call them whatever you want. That, unique types were going to solve the problem of garbage collection, and that we would be able to, do system programming in memory safe languages. In fact, I believed in it so much. I spent 3 years of my life developing a compiler, which was called Linear ML, which was a version of ML with linear types. So very much like Rust before its time, with an ML syntax and without mutation. I used to believe that, this stuff was going to solve everything. And now I don't know. So part of me really wants Rust to succeed. I mean, succeed. It has succeeded in some way, but like kind of overtake the world of system programming. And the main reason is I dislike C++ so much that I really would like to see it go away. But I mean, I have a hard time believing that, Rust is entirely going to conquer the realm of system programming. And here's why. So I'd say if you really care about performance, right? If you really want to squeeze out everything you can out of the machine, I feel like a language that is an ocean of undefined behavior is always going to have an edge, because the compiler has just so many degrees of freedom that it will be able to do more things than, a safe language. So some people would tell me, yeah, but there's unsafe in Rust. That's true, but given that it's not the default, there's unless all your code is unsafe everywhere, like to get the same level of freedom for the compiler, I feel like it's going to be a tough one to succeed in. And then the one thing that I'm happy with, though, with Rust is that they are taking over what I call the C++ bros. So I don't know if I ever told you this concept, but the C++ bros. So there are people who do C++.
Am I one of them before we get into this?
You're not one of them. You're not one of them. Let me explain to you what I call a C++ bro. So you've got people who do C++ for good reasons, like they want to actually, they need performance. They need to do low-level stuff, like building a JIT. Fine, completely legit. So I'm not talking about that. I'm talking about people where you talk to them, you're like, hey, Bob, why are you writing this in C++? This is a very, it's a very simple service that you could run in Java and Go, and the answer is like, because it's fast, bro. and so you go in, you look at the code, and you're like, that's not fast. You're copying everything everywhere. Oh, wait, there's undefined behavior here, there. And you're like, well, and so for these people who are using C++ because, GC is slow and because they're fast and, because they're the shit, if they could all switch to Rust, great, right? But I think that the serious hardcore, system programmers, I think they will always need to do enough dirty tricks that I don't know that, Rust can take over. Now, don't get me wrong. I hope they will. I hope Rust destroys C++ because I hate C++ so much.
And we host we host a weekly Rust learners meetup Wednesday evenings at Pebblebed, by the way. So we have people who are, and the target audience is basically like, I don't know any Rust. Help me to get the Rust toolchain on my laptop and just teach me what's going on. And watching that population cycle through, the thing I'm sort of grateful to the Rust community for is just getting kids excited about systems programming and getting people excited about the potential of programming languages in a way. Because for a lot of people who don't think of themselves as systems programmers or don't think of themselves as PL people, they're having this experience where they're like, oh, this notation is making a difference, right? This different way of writing a program is making it easier to be safe in ways I care about. And it is making my program faster and sort of putting things in reach in terms of machine orientation that weren't in reach before. And so I think those are kind of positive things broadly. I think it demystifies some of the low-level machine stuff. If I had to rebuild civilization from scratch, I probably would still start with a C compiler, honestly, because that's where the productivity languages are going to come from. That's
we would change a few things, right? Like type defs and syntax for function signatures.
A couple path-dependent things aside.
I get what you're saying.
Yeah, a couple path-dependent things aside, right? There's unforced errors in C, and C++ inherited them all, unfortunately. And when you look at sort of some of these projects like Zig and Rust that sort of feel like these huge breaths of fresh air, there just used to be this assumption that one of the things that constrains Strip's views of what C++ had to be was that it had to literally compile C source code.
But it doesn't. Most of the time. I mean, it does in some cases. But
these days it doesn't. Yeah, these days it doesn't. At the time it had to for a while. Yeah. At least it had to be able to include the headers with the, with the right if def garbage. Anyway. We're off in a weird programming language rut when we meant to be talking about HHVM for a second.
All right, so let's go back to HHVM, which you wrote in C++. So tell us for a second why you chose C++, because I know Jason is a C guy. You were a C guy as well.
I was a C guy.
So was it Drew, or why did you choose C++?
A little bit multifactorial. First of all, Facebook's a C++ shop at this time, right? So the FB code base, which is a sort of back-end static language, has a build step code base to it, was primarily C++ code base. At this point, I'd been working in C++ for about a year and a half. So my first job at Facebook was working on the search backend, and because it was a C++ shop, I'd been doing
That's
C++.
where you met Jordan, right?
Yeah, that was where Jordan and I first crossed paths. Jordan DeLong, by the way, is one of our ex-colleagues on HHVM. The other kind of complication here was a big chunk of the HPHP effort was moving all of the PHP extensions into the code base of hip hop, right? So PHP is not just a core language, it's also sort of a thing that lets you output PostScript, and a thing that lets you parse PDFs, and a thing that lets you parse XML, and a thing that lets you read JSON, and blah, 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 all these, regular expressions, all of the stuff that you're sort of used to pip installing in Python land or whatever.
Isn't it why there has never been a JIT for Python? It's the same reason, right? There's so many extensions that make assumptions about, what's the
I mean, there
internal.
have been several JITs for Python, as a matter of
No, but
fact, right?
just for
But yeah,
Python, that actually,
that
took off.
yeah, they take over the
Right.
world. Yeah,
Yeah, take over the
that's
world.
a big chunk of it. Is that like the
Yeah.
whatever the runtime you have for that Python JIT has to look basically exactly like the C Python's runtime, or else. We should try. If I don't know if you ever talked to Sam Gross about the stuff he's doing about trying to get rid of the lock.
Yeah, he's trying to well, he did get rid of it, the
Yeah,
global lock, right?
it's
It's in,
it's
right?
a going
It's in.
concern. You can if-def it out now. The core of what became HHVM, right, which is the JIT compiler that we were ultimately building, in some ways is kind of like a C program, right? It's organized like around structs and is pretty procedural and is, passing around references to fairly flat data types and things like that. It's not, deeply C++ in the ways that were fashionable at the time. It got sort of more metaprogrammed, especially post C++ 11. But honestly, we're doing a lot of the metaprogramming stuff with C preprocessor in the early days of this, just because that was what I was more comfortable with. But anyway, we're getting into implementation details here. Why even do this, right? Like, why a JIT? Like, why would we do better than a ahead of time compiler? Why all that stuff?
I know. It's because
Go, Julian, go.
the interpreter was getting too slow. So it was taking, well, first two things.
Sure.
First, the interpreter was getting too slow. So the developers, whenever they were trying to make a change on their dev, because so that people know, on the HPHP setup, there was the compiler that was taking the PHP source code and producing the C++, transpiling to C++, and then compiling that to native. This is not what people were running on their sandboxes, because that process was super long and super expensive. So there was also an interpreter. And the problem with the interpreter is that it was really getting too slow. And so there was both the interpreter that was getting too slow, and the compiler also that was running into some kind of hard limit. Was it the linker? Was it the binary size? What was it?
So the hard limits were gonna be fixable. So among the hard limits it was running into was that it was outputting a binary that was greater than 2 gigabytes, and we know we were among the first people to try to do that with the GNU linker chain toolchain, because we were hitting into sort of signed 32-bit integer errors dealing with text segments basically in the toolchain. And these were just basically mysterious like crashes, or even worse, mysterious corruptions of the output binary when you get this big static binary out of this link process. We worked through them one at a time. That wasn't the thing that sort of was the death knell for HPHP, but it was an example where it's like, okay, we're really starting to abuse this tool chain from the perspective of what was engineered for. And then on HPHP-I, this thing was just sort of supposed to be there for these goofball PHP programmers who for some reason can't be bothered to compile things. We don't understand why. They must not be good at computers. But they get this crummy interpreter, and the crummy interpreter was a AST traversing interpreter, right? Basically had a big syntax tree in memory of the entire code base. It would incrementally update that syntax tree when you change stuff on disk. And if you can imagine the difference between sort of a bytecode interpreted, it's usually kind of an order of magnitude implementation improvement going from I traverse an AST to I run around switching on bytecodes, and then typically maybe another order of magnitude to get from that bytecode interpreter to native code interpreter.
And the first PHP interpreter was reading the file character by character, right?
Oh, so fun fact.
That's another order of magnitude, and it was implementing loop with lseek.
Oh, I didn't know that.
Yes.
Wow.
It was actually.
So this was a file pointer? Like it just was a file pointer?
Yeah, it was a file pointer that was moving.
Wow.
Back. And I mean, as far as I know, I hope I'm not making stuff up here, but that's somebody who told me this story.
We should try and get Rasmus Lerdorf on here sometime and get the lowdown. Rasmus Lerdorf, the father of PHP, by the way, which originally was like a very modest little project. PHP stood for personal homepage. The idea was like it was mostly HTML, but you wanted to like have a little integer in it that you read out of a database or something to be like,
which was the internet back then, right? It was the internet.
When it was like, you're the 1003rd visitor to this page. People just wanted to be able to do that, or they just wanted to be able to like do one little database populated field in the middle of a mostly static page or whatever. And that was the problem PHP was meant to solve, not some big complicated dynamic Web 2.0 thing like
Although
Facebook.
for arrays and references, I really would like to know what happened there, because arrays, and especially the way they interact with references and how, it's looking at the reference count to determine if it's going to copy or not.
Yeah.
That's for me is just,
There's some odd stuff there that, like, especially because the syntax is Perl-like and because, like, the culture of doing web stuff was very Perl-derived at the time, I suspect, and I don't know if anybody's copped to this exactly, I suspect there's a misunderstanding of Perl semantics. I'll put
I
that out
have a
there.
theory regarding references.
Please.
I think the theory goes like this. Like, they introduced value semantics, which, by the way, is great. I like value semantics. That's not the
We love
problem.
copying things. Yeah, when in doubt.
So the idea was you pass around an array. If somebody modifies this array, you're actually modifying a copy so that you don't affect the original array, which is very functional in nature. So I have no problem with that.
So
Except
far, so
that
good.
so far so good. Except that, well, when you make your copy, what happens when you hit a cycle, right? And the moment you hit a cycle, the easiest way to handle this cycle is just to look at the reference count and say, you know what, this could be a cycle. I'm just not going to copy this. And that's my theory, that, managing cycles would have been too hard and too expensive. And so the easiest way to get a copy on write that, worked reasonably well quickly was to just look at the reference count.
Okay, yeah, we're definitely like in PHP nerd corner here. Just super briefly, it is the way that PHP implements automatic memory management is with reference counting. When the count on an object goes to 0, it reclaims it. That's not such a terrible strategy. Lots of perfectly respectable languages do this.
But it's part of the semantics in PHP, so that's a bit different.
The thing we're referring to here is that it's programmer visible. That's how it implements it in the way that Julian's referring to, and that is unusual, and it does. And when you get down to trying to do a high performance implementation like we were doing in HHVM, it is a pretty heavy constraint to work around, and is one of the reasons that it'll probably never be competitive with Java or something like that, no matter how clever.
Like arrays, I mean, for me, arrays was the hardest stuff for the type checker, for all the problems were with arrays and references. A lot of it is actually okay. Like, it's object model. There are a few weirdness in it, like protected does not apply to your children, but it applies to the whole tree, because there's no object in PHP.
Right,
and so normally protected means it's something that anybody underneath you can, redefine. That's not the case in PHP. In PHP, protected means underneath and on the side, because in fact, you don't have a tree, you have a forest, because there is no object type. And so so this is weird, but, and also checking for visibility at runtime is weird. So they had some weird things, but frankly, nothing too unreasonable. But arrays and references, which is the bread and butter of, the language, that was like just very, very difficult to type check and get that in a good place, unfortunately.
One reason for why we thought a JIT was necessary was development environment. I think another implicit desire here was unify the two implementations, right? There was sort of a class of bugs which were the interpreter behaves subtly differently from the compiler. Some of this was, for example, degrees of freedom that C++ has that you didn't have in the interpreter. So if we're relying on the C++ toolchain to do things like evaluating arguments, the order that you evaluate arguments to a C++ function call, that's actually up to the compiler how it does it, which people don't expect, by the way. Like most C++ programmers implicitly
you
think
guys were running in sandboxes for a while, right? Before going to production. Yeah,
that's true. Yeah, we got to be into development environments for a while before we hit prod, probably almost a year, actually, now that I think about it, before we hit prod. And so we wanted to make it so that you'd run into the same bugs running in production that you're running in your sandbox. That influenced a little bit of sort of at least the early days philosophy of HHVM, which was like, instead of having, one of the ways to sort of get a promotion at Google is to like make a new gear for V8, right? Like, so V8's got, 27 modes now, right? Because everybody who makes a new mode for V8 gets promoted to senior staff engineer. But it means that the landscape of sort of V8's behavior is actually kind of jagged, right? And if you're an expert JavaScript programmer and you care a lot about how your code performs, it can be difficult to reason about how it's going to handle it. One of the things that C programmers, and good enough C++ programmers like about their toolchain is they feel like they're able to reason about the compiler's behavior.
I mean, C++ developers, come on. There's only a
Yeah.
handful of them who are capable of that. Like even at Facebook, even, in those kind of shops with top-notch engineers, the people who actually know what C++ does, a few.
You don't think they wouldn't be able to kind of like hand expand all the templates and everything and kind of be like, here's what this loop that reversed a string really would look like? You don't think they could do that?
I don't know. Maybe.
That's an
I
interesting
don't know.
question. I think it's possible. And maybe this is like a sign of the times. Like I came up in an era in the 90s, like they still made you take courses where you built little toy compilers and where you wrote a machine code and stuff like that.
But no, they
Anyhow.
do that now, but they just vibe code the compiler. It's completely fine.
Well, yeah, touche. You're
It
right.
just works.
Yeah. The other thing this is the reason sort of HHVM is what, JIT people would call a baseline JIT. It basically was like just trying to do an okay job turning your PHP into machine code. It wasn't 15 different layers of optimizers on top of that were going to, optimize, then de-optimize, then re-optimize, then inline again, then re-optimize a third time and blah, blah, blah.
And you had to fight a lot of people who wanted to build things like that, right? I remember back then there was competing projects. There was a team that was attempting to compile to the JVM, if I remember well. And you
That's right.
also had people within the company who wanted for you to target the JavaScript V8 because V8 was all the rage back then. Now there's, a little bit more diversity.
The actual hackathon project I worked on that was sort of the dawn of HHVM with Jason Evans and Drew Porosky was actually V8 targeted. Like we were jitting to JavaScript. We were sort of translating PHP to JavaScript and then running it through V8 and kind of got the programming language shootout benchmarks or some subset of them working a little bit and said, look how blazing fast this is. But yeah, V8 was an inspiration at the time. I think I also, was coming from VMware, which was a machine level JIT, right? The software only version of VMware took unsafe x86, spit out safe x86, and that was how we were able to run, Windows on Linux and Linux on Linux and FreeBSD on Linux and so on. It didn't try to make the code faster. It just tried to sort of preserve reasonably linear slowdowns and where possible, zero slowdowns. When there had to be a slowdown, make it a constant factor. And as long as we did that, we knew we'd be at least able to sort of boot and run Windows in an acceptable fashion, and that was what our customers needed.
Dude, I remember once, sorry to interrupt, but we were at Epic Cafe.
No.
We were having lunch, and you were ranting about, people who wanted to run some kind of optimization on HHVM, and your whole approach was, we don't need to. We just have to translate the bytecode into, native code, and it's going to be good enough. And I'm with my bagel in my mouth, and you're like, Julian, there is no amount of money you can give to compile a person not to implement those optimizations. There's just no amount of money I can give them to say, no GCE, no people. It's not happening. Right. You're not doing this.
Yeah, it's an unnatural act for them, right? Like it's like they've got this enormous bag of like awesome tricks to make code fast. Like why would you just not make the code fast when you can make the code fast? The problem with running PHP wasn't, that we failed to strength reduce multiplying by 5 into shift 2 and add a copy, right? The problem with like your PHP not being fast was that like it didn't even know it was a freaking integer. You know what I mean? The problem with not being able to run PHP fast was like you're sitting there being like, is it a string? Is it an array? Around this time, we were lucky to have a little bit of literature support here too. There was the term the repurposed JIT phenomenon kind of entered the programming language lexicon with a publication around then, which is basically when you are building a just-in-time compiler for a language, you're implicitly making lots of decisions about what to make fast and what to make slow. And those decisions are going to be basically tuned to the characteristics of the language that you're supporting. So for example, we talked before about the fact that PHP uses reference counting and that it exposes that to the programmer. If you want to piggyback on something like the Java virtual machine, well, the Java virtual machine's got a tracing collector and it's, incredible thousands and thousands of man hours have been poured into making that tracing collector amazing. But no matter how amazing it is, you're going to be basically paying to garbage collect twice by running reference counting on top of this tracing collector. So it's really, really hard to kind of make up a gigantic headwind like that out of the gate, no matter how smart your compiler is. So trying to recycle another JIT we thought was going to be a loser. We thought PHP deserved its own first class thing, the same way JavaScript had V8, the same way VMware had to make its own thing for the x86 because the x86 doesn't look like anything else. I thought PHP didn't look like anything else either. And if you've ever worked on one of these systems, by the way, like this was true in the early days of VMware as well, there's this terrifying thing where for sort of, 18 months to 2 years or something, just nothing works. And your professional life is full of people saying, KMA is an idiot. This thing he's saying is foolhardy. It's a big, it's a big hole in the ground that we're pouring money into, and it won't work. And they have a lot of evidence on their side because they basically have 6 quarters in a row of me saying lots of stuff that sounds good, and what works? Nothing. Right? The site doesn't work. People aren't able to use it, and so on. So we were really happy when we got to the point where the site runs, because at least we can get a little bit of win here, where at least it's faster than the old school interpreter, and at least we're getting a little bit of benefit from it. However, one thing that was concerning is that the day that we first were able to run the site, remember the whole point of this project is that we wanted to run fast. And when you compared the JIT's version of the site to the ahead of time compiled version of the site, the approach that we thought was inferior and that we thought would be able to blow the doors off of, we were something like 10x behind. It was more than that, I think, but like 12, 14x, but like a discouraging distance, like an ocean to swim across in terms of performance. And, you find a couple of low-hanging fruits, right? You profile a little bit, you find a few things right out of the gate, and you get that down pretty quick. But it's like we got it down 2x, so now it's 7x behind, which is still really, really far. And the profile looks really flat, right? There's not one place where it's all going. There was like a week or two where I was basically just like, well, shit. I may have made a really major mistake with my career and the career of the people who bet on me here. But what we eventually ended up doing was just kind of taking in hindsight, what I now think of as sort of a machine learning approach, which is like, no, the fundamentals are still on our side, right? The truth is out there somewhere. There is some way better JIT to build than this one. We just don't know quite how to get there, and it's not going to be one step to get there from here. So we got the team together, got some pizza, got some beer, and spent a whole bunch of hours just kind of covering a wall with Post-it notes of optimization ideas. And at this point, the thing was kind of mature enough that most optimization ideas actually didn't pan out. And it wasn't because they were bad ideas. It was just because, like, computers are frustrating and hard because performance is elusive. There are many ways to be slow and few ways to be fast. And what the mental transformation I've learned you have to make in these environments where you're past the easy part of doing performance work is you have to view the work as just pulling the Post-it notes off the wall, right? The work is just, I took this thing and I tried it. And maybe it worked. Awesome. We're closer to the goal, but maybe it didn't work. Who cares? There's fewer things on the wall and we know more now, even if all we know is the things that won't work. So the mental shift of like, I now get the dopamine hit when I take a note off the wall versus I get the dopamine hit when the thing goes faster is a really important transformation to go through in one of these things, right? If you start to view it as like, this is just a search process, it's out there somewhere, we will eventually find the right veins to mine, even though I don't know what they are right now. And, it can be a great day at the office if we didn't make anything faster, as long as we pulled 10 notes off the wall today. That's still a lot that we know today that we didn't know yesterday, even if all we know is about things that didn't work instead of things that do work. That's still going to mean we put better Post-it notes up tomorrow. That's still going to mean that the ones that we haven't taken down yet are more likely to be where the juice is. And then once you started getting rolling on this process, it kind of took on a life of its own, right? Like it kind of, you get into this rhythm where you just show up every day and that's what you do. And it starts to be kind of habituating, right? Once we got through from 7X, Jordan DeLong actually found something really early on that was a gigantic win, like a weird 14% win. It changed the way that we thought about this because there was nothing in the profile that was 14%, right? The part of the system that Jordan optimized wasn't taking 14%. So how did it make it 14% faster? Well, it turns out caches explain a lot of weird mysteries that Amdahl's law will hide from you if you're thinking in terms of, we have to spend all the time on the thing that's the top of the profile. Caches are this, mysterious medium that can cause this part of your program to slow down that part of your program. And it was a really important clue. And we started sort of digging, pulling on those threads more actively once we had that clue. And And once we got through parity, once we got to 100% of the performance of the production system, it was a lot of ton of momentum. And then the week after that, it was sort of we were 10% faster. The week after that, we were 20% faster. And pretty soon, Zuck was in our pod ringing the gong to turn it on in production.
I remember that. So I don't know if you remember this story, but this was maybe a few weeks before you guys were going into production. And back then, I was in your team meetings because Hack had been merged with HHVM. So Hack was before a team of its own. And then Polbar was actually the one who pulled it in. So, Polbar became the manager of Hack. And that's what
Joel Polbar, by the way,
Joel Polbar, who's
awesome
now
guy.
I mean, he's back at Facebook now, right? Like he's been brought back to run AI stuff, and I mean, great guy. He was at Anthropic
briefly, then back to Facebook.
Exactly.
Yeah,
I don't know if it was that briefly, but I mean, I think he's back at Meta now. I remember you guys are churning to get to parity, right? And from the last meeting, I know that there's just 8% missing to get to parity. And I show up at your pods and there's you, there's Jason, there's the whole crew. And I'm like, hey, Keith, so, I was working on a task on dub recently. I think it's, some minor stuff. And, I noticed something strange that, I feel like my code could be a little bit faster, like 8% faster. Do you think you could do that for me? The whole team was like looking at me like shut the fuck up.
Cranial smoke, right.
With smoke coming out of the ears. Really, you're doing this? And again, I mean, HPHP was still optimized back then, right? There was still
there was still going. We were drag racing, moving target at that time.
Exactly. So it was 8%, but it could have been 12 the next day if there was, because I mean, you kept it fair the whole time. You never, there was never any push to prevent people from optimizing HPHP. And I think that's great because this was fair game the whole time. You never said, all right, you people who are still optimizing the old system, stop doing what you're doing. It's obvious
the old system probably got about 3 times faster over the lifetime of the project. Right?
So,
the old system got a lot harder to compete with.
Yeah, exactly. And so then came the gong. When Facebook HHVM got into production, and then what happens after that? Then you're kind of knighted by Zuck, and then people just bow as they see going through the corridors. What's going on after that?
I mean, you heave a big sigh of relief, right? Me and Joel, went shopping for a cake. we had a little party for the team, because everybody did pull pretty long hours to get this over the line. And then after that was kind of like back to work, right? So there was still, there's still a bunch of Post-it notes on the wall after that, actually, right? So you said, well, okay, we still got all this roadmap. And he kept kind of just burning that roadmap because, every 10% of CPU you save is billions of dollars of essentially profit margin for the entity Facebook at that time. To be clear, there's like a bunch of tooling that we relied on that other people built that was amazing, right? I'm thinking right now, PerfLab, for instance, which like had a bunch of really interesting tricks and a lot of pretty sophisticated statistics to make the...
There's a lot of cool stuff that came out of Facebook. I mean, React came out of Facebook at this time. GraphQL came out of Facebook at this time. It feels like those early 2010s for me were like the best, engineering time of my life. Like it seemed like a bunch of really smart people who just wanted to get shit done and who were moving super fast and building a ton of interesting stuff. And wherever I go now, I'm trying to rebuild that vibe, re-get this vibe of Facebook 2010, Facebook 2011, 2012, around there. That's really the time that for me was the peak of, interesting people all over the place. You wanted to know anything about the kernel. You had a bunch of kernel experts, the best in the world. You wanted to know something about programming languages. You had we hired Simon Marlowe. We hired, and there was interesting
from the
people
Haskell community,
left and right. Yeah, the Haskell compiler guy. And yeah, it was a great time.
There was something sort of in the air in hindsight where there was a lot of fearlessness, a lot of willingness to try new things, a lot of conviction that you can kind of blow up the way that we've been doing things and do it in a massively better way. And a lot of positive examples of people actually achieving that.
Yeah, exactly. I think it's a rare thing when you work in a company where people are convinced that they can build the next big thing.
Yeah.
In most companies I worked for before Facebook, they always believe that whatever the other guys have been building is better, right? And Facebook was not like that. They thought, no, we can build something better, and if we just put enough time and enough energy into it, we can do it. All right, everyone. Thank you for listening. It was really great to spend this time with you guys. Thanks, Keith.
Likewise, Julian. Thank you.